Yeah. So the idea is that this, because it's a CH3, it's an acete group. So then it's acete aldehyde. Because acete literally just means ending carbon.
And then you have to be
Whatever.
like the same.
And so like whenever you see like,
acetaldehyde,
like-
is the same.
yeah,
Acetone is the same.
yeah,
Acetic acid and carboxylic acid is the
yeah.
same.
Where does that come into play with identifying the enzyme?
Nothing. He was just
No, because the kids,
we were just talking
we need
about
to
it.
learn those anyway. Like those,
I mean,
Are those the
according
common?
to my conversation with Dr. Pelfrey,
Those
he
are the
said
common
no.
names, yeah.
But I know a lot of people are like, someone's mentor said, you know, like you
You
have to
can't
learn
trust him?
everything, or
Yeah.
you can't trust him. And I'm like, yeah, but I mean, it's one of those like, if we end up having that stuff, I almost cussed again.
person.
If we end up having that stuff like acetaldehyde and stuff like that on there, I'm gonna be like, yo, like you said we didn't have to learn these. I was telling people they didn't have to know this, and therefore you're making me implicated in their grades or whatever. But at the same
That's
time,
arson.
at the same time, I don't think he's gonna have too much in terms of like knowing these. I think it's gonna be more, he's gonna give you a big structure and want you to actually identify like functional groups. Because like memorizing these don't really matter. Like you don't really care. The only thing we really care about is formaldehyde, because you know that's what the morgue smells like. Yeah, I'm gonna do blue. I'm gonna let them green, red, and black.
Anything with the double O on top and that H on the bottom left starts with form, whatever that name is.
Right. So
So an H.
idea is that we should be able to identify that this is a redox reaction. That is the extent of what he really is expecting from you guys. And just know that oxyreductase is what does it. I'm pretty sure it's supposed to be like oxidoreductase or oxidoreductase.
Oxidoreductase, yeah.
Yeah, but whatever. I don't think he really cares if you know how to spell oxidoreductase. So I just say oxyreductase. So the idea here though is that if you actually wanted to understand what was happening here, you are creating this intermediate right here, right? So this is CH3, CH2, and there's an OH here, and this is CH3C, and there's an H here. And so the idea is that one of these hydrogens is leaving this carbon, and one of these hydrogens is leaving this carbon, or this oxygen, in order to create this double bond here. So what happens is you've got your CH2 here and CH3 here. These don't really matter, but we have it there just because we can. And what this, so with this hydrogen here getting lost, which is this right here, you have a negative oxygen here, but oxygen actually really likes having two bonds. So this here is going to drop in and create a bond here, which then gives us this intermediate. I'm not going to write in CH3 anymore. So I'm going to write in CH2 here. With the idea that this CH2, oh, the blue does not erase there, it goes all the others do. You've got H and H, right? Because that's what CH2 is, H and H. So now this carbon has 5 bonds. And carbon doesn't like having 5 bonds, it wants to be 4. So oxygen really likes having 2 bonds. Carbon really likes having 5 bonds. Oxygen's a little bit more forceful, we'll say, than carbon is. So carbon is more likely to just kick off one of these hydrogens. So then we have another hydrogen that's getting lost. So in the process, we lost one hydrogen up here and another hydrogen down here. And in the process, we're increasing the number of bonds for oxygen. Okay,
So that's why this is a redox reaction, it's affecting the number of bonds for oxygen. And this gives this, because after that hydrogen is gone, it's this structure here. So in the process, we're losing 2 hydrogens, which means that we're losing 2 objects that are basically like electron, what's the word? Electron holders, we'll say. So one of the big things that people always used to like do like oil rig or whatever in terms of like the oxidation is loss, reduction is gain thing. So the idea is that like if you're reducing something, you're gaining electrons. Because we're getting rid of 2 H pluses, you're actually reducing this in order to gain all of those electrons from those hydrogens. But in terms of what he wants us to know, if you see an oxygen that has 1 bond and then now it has 2 bonds, that is the extent of what he wants you to know. He does not really care about you knowing any of the rest of this happening. That's all he cares about right there. With the idea that it only really applies if you don't see anything else really changing. Like this changing, this NADPH or whatever, all it's really losing is a hydrogen in the process of this. We don't really care about hydrogens. But if this was an ATP or something like that in the process, it could be a little bit different, because if you're using phosphate or something else like that in the process of doing this, it could be some sort of transferring. But if you don't see, like if you see ATP, you just automatically assume that's a transferase because it's using phosphate. But if you don't see an ATP, if you don't see something else that's transferring something to something else, if it's just a loss of hydrogens, it's a redox reaction. Redox only really involves hydrogen, oxygen, and occasionally nitrogen.
So we lost hydrogen in both?
Yeah.
Where did they
They're just gone. Usually there'll be, so because we're losing 2 hydrogens in the process of doing this, usually there'll be a free oxygen in here that will pick those up, and usually you lose water. So sometimes he might show there being like NADPH plus H2O, or there might be a plus H2O over here. Because that's all that's really happening. There's oxygen involved in this reaction that creates water and this acetaldehyde.
How does that differ from the acetyl substitution? Doesn't acetyl also form water? Or is it redox? Maybe it's redox.
There's a lot of reactions that just form water. You're thinking of like the dehydration hydrolysis
Maybe.
reactions.
So if there's anything else, if it shows ADP and ATP, most likely we're gonna have a transferase. If we have a single bond going to a double bond with oxygen, it's likely gonna be a redox.
Yes. If you ever see this OH, what you're probably thinking of is like in terms of like the like losing of water. If the whole OH group goes away to make water, that's what you're thinking of in terms of like a dehydrogenase. But once again, don't have to worry about stuff like that. Just looking at what's here and what's here. Turn this off again.